Hello, and welcome to another Into the Terminal. Today, we're going to be talking about network configuration. So, bear with us. Producer Eric is on vacation, so I'm both producing and demoing today. So it'll be a little bit clunky, I think.
I don't know who let him go anywhere. I mean, really.
His manager should be fired.
Yeah,
All
totally.
right, so just jump right into the terminal. And what we're looking at here is a RHEL 9 system. And the real kind of key to networking on RHEL these days is moving away from things like the network script files that we traditionally use, ifcfg configuration files, and instead into network manager native things. So the network manager command is nmcli, and it supports bash completion. So if you hit tab a couple times, it'll tell you like what the component commands are. So I could do things like look at the connection that I have on the machine. We can see that this machine has three interfaces, two Ethernet interfaces and one loopback. We can also do an nmcli dev, and it'll show me the devices that are connected to the machine. So in the event that I didn't have an activated device, but it was present on the machine, we could see it here in the list of devices, but it wouldn't necessarily be reflected over in the connections. All right.
A nice note is that those connection names can be a little friendlier, right? Like sometimes you'll see wired connection instead of ENPS3, right? So just something that's useful, right? Something that you couldn't do easily in the old days that you can do now under Network Manager.
Right. And that plugs into things like the graphical network tools that are coming with desktop interfaces so that you can actually pick off the list with a more human friendly name.
Right.
All right. So if I wanted to disable one of these connections, so first let me show you using our IP command that I have two different Ethernet connections, ENP0S3, which has a couple of IP addresses assigned to it, and ENP0S8, which also has an IP address connected to it. So if I wanted to disable ENP0S8, I'm going to nmcli connection or con down EMP0S8. Right, and it's successfully disabled the connection. If I look at IPA, right, down at the bottom under ENP0S8, we used to have a bunch of IP information. Not there anymore because we disabled it. And if we want to turn it back on, we can connection up it. And this is configured via DHCP. So when I do the connection up, it'll actually do a DHCP lease negotiation automatically. And when I look at the IP information again, we can see its IP address is back. And we'll take a look at some of those additional configuration parameters in the deeper dive. All right, so to give us a taste of what we're going to see in the deeper dive, I'd also like to show you the additional connection information that we have for every configured connection. So if I do an nmcli connection show, and I tell it the name of the connection that I want, it'll actually give me this list of parameters, and it's huge. Um, these are all the configuration parameters that one can change associated with this network connection. And so you could see things like the interface name. So some of this gets auto-populated from system information. Down a little bit further, oops, go back. This IPv4 method, right? So remember, I said that this was a DHCP address obtaining interface, and this is why, because the IPv4 method says automatically obtain the network address. And Nate's going to take us through in the deeper dive on how we might change that to something else. You also get some additional parameters like IPv4 network stuff that we'll see a little bit later. And there's also the IPv6 network stuff that you can change. And all of these changes and all this configuration is stored in a backend database used by Network Manager. So as we're making changes with nmcli, it's actually making those changes to our system as well as persisting them in the backend database so that if we were to reboot the machine or turn the interface off and back on again, it comes back with the same parameters that we left it with. All right, so that's a little bit on nmcli. Nate, any words of wisdom?
Uh, Embrace the nmcli. I guess is the best I could say. I came from the old world of network scripts as well, and it was a little bit to figure out how nmcli was changing things. But once you get used to it, it's actually a pretty nice setup.
Yeah, and one of the things I think that as we were discussing the show, that came up is, people struggle with making the edits. They used to make edits to a file and then apply those changes with an if down, if up with the interface. So
Hmm.
nmcli does the same tasks, but instead of editing a file, you're just executing a few commands, which from
Hmm.
a scripting perspective or an
Yes.
initial setup is actually more automatable than stream editing a file and hoping that you wrote the right regular expression to change a file.
Yeah, and the other thing is because it's in a database instead of a flat file, the changes can be read in on the fly, which we're going to kind of show when I start modifying connections after the break.
All right, so don't forget to mash that like and subscribe so that we can continue making great Into the Terminal shows. When we resume after the little transition graphic, Nate's going to take us into changing an interface from being a DHCP configured interface to a manual configuration. So, what are the commands that we need? What are the additional parameters that we need to supply to our network manager configuration? We're also going to talk about adding an alternate IP and making some other associated network changes like DNS settings. All right, then we're going to shift gears a little bit and talk about some of the more advanced things you can do. So, if someone is feeling nostalgic for the network scripts, I would remind them of what kind of experience they had when setting up network bonds on a machine. So we'll talk about what network bonds are, and then we'll actually do a configuration of a network bond uh, using Network Manager and RHEL system rules, which is a little bit of Ansible that we can automate tasks on our machine. And then we'll finish up just referring to some additional documentation and a lab where you can try using this on your own. All right, stay tuned after the break. All right, we're back.
Scott, I have nightmares about the days when I used to have to use network scripts to set up bonded VLAN network bridges for my virtualization machines.
Yes, no lie
You're
on that. And
so much easier
uh,
now.
yeah, nmcli itself has made that easier, but I think when we couple that with RHEL system rules, even easier. And I've already got
Or the
a,
web
a
console.
demo set up. Huh,
Like
also,
speaking of
yes.
things that Network Manager enables, the web console makes, if you use it, web console makes network configuration a couple clicks and boom, I've got a bond or boom, I've got a VLAN. It's great.
Um, so now's the time where if you're watching live, you can interact with us and ask questions in the chat. If you are a deferred viewer, please feel free to leave a comment. Both Nate and I will respond to comments and questions left in comments as well.
Yeah.
All right, Nate, should we jump into the terminal?
Sounds good to me. All right. So let's say, a lot of times you add a new network interface and out of the box it's set up for DHCP. Because that's kind of the default anymore. But a lot of data centers, they don't use DHCP, or maybe you've got reservations in your DHCP server, in which case you're fine. But if you're trying to set things for static, then you're going to have to know the commands to run to switch it to static. In the old days, that was like go into the config file for the interface and either make a bunch of changes programmatically through scripting or type them all in there. Or, there were some setup TUIs and whatnot that you used to be able to use. But with nmcli, it's actually just one command. So let me just copy and paste it here to show you how easy this really is. So first of all, I've got a, let me show you the interface we're going to be working with here. I added a second interface using the dummy network driver right here. Because if I were to change this interface, I would lose my connection to my machine. So didn't really want to do that. So what we're going to do here is, I have to recopy my thing because I just wiped out my clipboard. If we show dummy 0, I don't know, I guess this isn't as helpful as I was hoping for, but in here, you'll see that the IPv4 configuration is set to auto. We can grep 4 to show that. Here we go. IPv4.method is set to auto, right? So what we're going to do is we're going to switch it to manual, and we're going to give it an IP address, and we're going to give it a gateway and a net mask and everything all in one command, which I think is actually pretty sweet. So you can see here we got nmcli connection modify, and then the name of the interface, and then we've got IPv4 method manual that tells it to switch it to manual mode instead of DHCP. IPv4 address is, of course, I just made up a non-routable 10 dot whatever address. The /24 defines, of course, the prefix, which will tell it what its net mask is going to be. IPv4 gateway, that tells it how to route its traffic, right? So if you were setting up the primary interface on this machine, you'd have to give it a gateway. Otherwise, your machine wouldn't be able to reach anything else. So we're going to hit enter, and you can see it doesn't really tell us much. But now if we look at nmcli con show dummy 0, let's just do a con show. And you noticed before maybe that this one is yellow while the other ones are green. That's because I had made some configuration changes to this while I was setting up my my lab, and I had forgotten to reload the interface. To do that, all you have to do is tell it to bring up the interface. So if we do nmcli con up and then dummy 0, it'll actually apply whatever changes are pending, right? So that's what I was saying about the on-the-fly changes before. I don't have to bring the interface down and back up. If I just tell it up, it'll look for things that have changed and apply them. If I do con show again, now dummy 0 is green. That means that there's no pending changes waiting for it. If it were down, it would show, see down here, we've got this lighter gray color that it shows up. I guess it's uncolored, I think is what it comes down to. If that particular interface is down. All right, so now it's actually, if we were to search again, we can't grep for auto this time, we'll grep for manual. You'll see IPv4 method is now manual. If we were to grep for, or sorry, it's IP. No, it's not IP, it was address. You'll see that it's got the 10.10.1.2 address that I had given it. And if we do an IPA, it's going to show us that dummy 0 now has that IP address assigned to it. Before it had none because there's no DHCP server to actually apply anything to this dummy address because it's not actually connected to a network, right? So the next thing you might be curious about, right? I've done this a lot in my web hosting days. You've got several services or several websites, in my case, running on the same machine, and maybe you want them separated by different IP addresses instead of using virtual hosting. Or maybe you have several services, or maybe Docker containers or Podman containers. I do containerization on my my systems, and in order to make those services reachable, sometimes you just map the port, but other times, if you've got two containers that talk on the same port, you need to add more IP addresses. So that's the way I do it for those. So to add another IP address, again, with the network scripts model, you either had to add a sub interface or there were IP alternatives, if I remember correctly, that you could specify within the network script. Here, it's just another nmcli command. So we're going to do a connection mod again. Give me just a second here to copy it out of my clipboard or out of my notes here. So now we're doing nmcli con mod again on dummy 0. And this time, see there's a plus here. That says add another entry for IPv4 addresses or address, right? And then we've got 10.10.1.3. And just for fun, I added a second one too, just so that you can do this for more than one at a time, right? So we're adding another one, 10.10.1.4. If you wanted to go crazy, you could do like a for loop that adds 128 IP addresses to this interface if you really wanted to. And what that'll do is it'll put it into the configuration, but it won't apply it until you do that con up again. So we're going to run that. And again, if we did con show, you'll see, oh, it's not yellow this time. Did it apply it right away? Let's see. It didn't. All right, so maybe I was wrong about those colors. All right, so if we do nmcli con up again on dummy 0, you can see it's successfully activated. If I do IPA now, we've got 2 more addresses added to that particular interface.
And
so,
Nate, another great practical why one would do this. You know, over the last few weeks, we've talked about things like services and binding services to specific ports or containers being bound to a specific port. Well, if you only have one IP, then you only have one port 80.
Yep.
If you have 3 IPs, all of a sudden you now have 3 port 80s, which means you could bind different containers to listen on the different IP addresses, and you can customize what traffic goes to which of these bound services based off its IP address.
Yep, that's exactly it. In my case, game servers are a perfect example, right? Again, I'm using the home lab as my example here. In your home lab, maybe you've got 3 of your favorite game server running for different, uses, different groups of friends or whatever, right? Game servers generally run on whatever port they're told to run on, right? They're not always as configurable as some services are. So you're going to have to open up more ports, and you can map different ones in, but then it's harder to find. It's harder to tell your friends how to connect. But if you have separate IP addresses, then you can map those in through your firewall or whatever it is that you have to do to the specific IPs instead of having to remember what port is what. All right. Let's see. I had one more thing I think I wanted to show. Right. Name resolution. That's another thing that's kind of changed. It used to be you just edit etc resolve conf. Now, I think if you look at resolve conf here, let me clear the screen so you can see better. At the top of resolve conf, there's this warning that says that this is generated by network manager. If you change this, network manager is going to overwrite it next time it reloads, right? So you used to just write directly in here. Now, not really recommended anymore. It's kind of like if you have automation that manages the resolve conf or any other config file. You make changes directly to it, there's a good chance they're going to get overridden. So the way to get around that is there's nmcli commands that will let you set name servers. So let's go paste this in here. And these don't necessarily have to be per interface. I forget if you can do this without specifying an interface, but I don't want to go off script and see it explode. So in this case, what I'm doing is I'm telling it that this connection needs these name servers applied to it. So there's a key called IPv4.dns. You pass in a comma separated list of values, and it'll set those name servers. Uh-oh. DNS server is invalid. What did I do wrong? Do I need single quotes? Hold on. Sorry, I did test this before. There we go. Maybe the quotes might have got messed up in the... We use Google Docs for these things, and Google does weird stuff with quotes and dashes and all kinds of crap. So anyway, now, if we were to do a con show on dummy 0, and we're going to grep for DNS, Nope. I have to put grep in there. DNS is not grep. It's a tough one. All right, so now you see IPv4 DNS is in there, and then I just blocked it with a clipboard. We want dummy 0. Now if we cat resolve conf, ta-da, we have 8.8.8.8 and 8.8.4.4 added as name servers, right? So nmcli, or network manager, I should say, added those in there. Now, the other thing that is usually important is the ability to add a DNS search domain, right? So if you're not familiar with DNS, if you're searching for a host name that's in your search domain, you don't have to type the whole search domain out, which is really handy for things that are local. You can just say like SSH into server 2 instead of server2.whatever.com, right? So how do you set the search domain? Well, guess what? You can also do that with nmcli. We're going to copy and paste, and then we've learned from our mistakes. We're going to replace these quotes that have been messed up on me. So I'm telling it to add the domain somedomain.com to my search domains on dummy 0. And then we have to do the con up again. And then if we cat resolve conf, it should be added to our search domains. Yep, there you go, somedomain.com. Don't go to somedomain.com. I have no idea what's on that domain. I'm sure someone's got it, though.
Surely they do. Example.com, a great one to use for examples because it was put in the RFP as an exemplar, and no one can actually get example.com.
Oh, well, I'll use that from now on then.
Yeah. So we've had a couple of questions come in, and I think now is a great time to answer some of them. So Nate, Darth Vikes asks, why did it go from interface names of ETH0 to strange names? And how do we get those back to normal, or how do we change what the selections are?
So, to be honest, I've got a vague recollection of why and how these are named. You may have a better description because I only dug into it once a very long time ago when I was a frustrated sysadmin and installed, I think it was RHEL 6, maybe it was 7, and all of a sudden all my interfaces were weird. But it has to do with how and where they're connected physically on the hardware bus now, doesn't it?
Yes, as well as data provided by the BIOS, and there's a couple of things. So there's actually like two competing technologies that will affect this. So the first one, and this is where I think you came in with RHEL 6, there was a technology called BIOS DevName. And the idea was that we would collect information from the BIOS of the machine from the manufacturer to then name our interfaces because the order in which the boot process walks along the bus may differ for different hardware, and
Yes.
all the manufacturers will have like a sticker on the back that numbers or names the port on the back, and we wanted to make sure that the name in the OS matched the name on the sticker. And so we worked with the PC manufacturers using this BIOS dev name standard so that we could actually do that.
Yeah, if you've ever had ETH0 and ETH1 switch on you at boot time because UDEV loaded in a different order for some reason, you'll know the pain there.
Right. Or like just different manufacturing runs of the same chassis would be slightly different, and that
Yep.
would cause weirdnesses. And so BIOS dev name was the first thing, and that's where the like ENP0S8 came from. So EN says Ethernet, P something it's port number, and S something says socket number. Maybe it's PCI card number and socket number, something like that. So those things mean something, and it is fed by BIOS. So sometimes they get weird numbers assigned to them. So I saw that Shantanu had also answered this question, and he mentioned that you can pass a couple of kernel command line arguments.
Yep.
at boot time. So if you add these to your grub kernel arguments list, if you say BIOS def name equals 0, it says even though the BIOS names exist, ignore them for the Linux kernel. This other one, netif names, talks about the second technology, and it's called predictable device names. As the idea was that
Predictable.
we could like predict what the device name was going to be and then like use it. However, like the data that we use, it does assign device names in a repeatable fashion, but the actual names it chooses are not predictable by humans. So it's kind of a misnomer. It's predictable for the machine, but it's not predictable
Right.
for us. So netif names equals 0 is a command line parameter you can pass that will disable predictable device naming. And so the both together, you'll go back to like eth0, eth1. Now, there's also some other weirdnesses, like it's a VM. Does a VM have a BIOS? Does that BIOS
Right.
recognize CI cards and sockets and stuff? So it could be that your physical hardware is using BIOS def name, and your virtual hardware also has it enabled. But because that data is not being passed by the BIOS, you end up with E0, ETH1, ETH2, and so forth.
Yes.
Um,
I've seen that in my own
so
VMs.
yeah, um, so that's kind of where the device naming stuff comes from, and it started earlier in RHEL. Predictable device naming came out in RHEL 7, and so since RHEL 7 is now out of its normal 10-year life cycle, um, all active versions of RHEL use both BIOS def name and predictable device naming. All right, here's another one. Is nmcli by default installed on RHEL?
Yeah. I mean, how else would you modify your your network interfaces? NMCLI is part of Network Manager. It's the tool that's used to tell Network Manager how to configure your devices. So yes.
Right, and so starting with RHEL 7, Network Manager was part of the default package set. So that's what does networking. And even though Network Manager previously had allowed for interface configuration files, the older System 5 way of managing interfaces, um, it was actually doing some translation layer stuff to get that into Network Manager speak. Network Manager started off as a graphical tool to help people configure their network interfaces. Um, and that's why it uses a database and its architecture is very different. And so I think it was Shantanu asked, like, why did we go to Network Manager? And it's like, well, we wanted to make things easier for desktop users. And
Hmm.
as part of that, we figured out that, oh, wait, there's actually a whole bunch of additional parameters that we can configure outside of what's currently offered in the interface config file method that is really old. And so Network Manager kind of started to be further evolved and
Yeah.
was the default in RHEL 7, but you could change it to use a service called Network Ing, which would turn it back to the ifcfg scripts. RHEL 8 is the default, and we recommended against using ifcfg scripts. And in RHEL 9, it is the default and only.
Yeah. I remember on 7, it was, I forget what it was. There was something that I couldn't do with it. So I had switched all my 7 boxes back away from Network Manager to networking. And on RHEL 8, whatever that problem was gone. So that's when I started using Network Manager again. And Network Manager always felt like this was, this is meant to solve a desktop problem because that's where its origins were. It was, imagine, your new, let's just say Fedora laptop, and I want to configure Wi-Fi. Well, Network Manager is a lot easier to configure a Wi-Fi adapter than the old style network scripts were. You could do it, absolutely, but it wasn't as easy. So that's kind of where it came from, and that's why it had that feeling at the beginning. But it's very much not the case anymore. It's definitely a server class network manager. Has a lot of
Yeah.
features that were tricky with the old style networking.
And in fact, that's a great segue for what we're going to talk about next, which is bonding. So, Nate, can you tell us a little bit about what bonding is?
Sure. So bonding, I mean, if you imagine just the word bonding, it's to take two things and bond them together. Well, in the networking world, bonding means that you take several network interfaces. It doesn't have to be just two. You could have four or eight of them, right? Maybe they have diverse paths back to your data center. Maybe you do it for bandwidth, however, there's lots of ways that you could do it, but it takes them and bonds them into a single virtual interface, which then shares the redundancy and shares the network throughput, right? So in the days when you were running like, you know, only gigabit or only, I say only gigabit now, like gigabit is slow, but when you had only gigabit and you were like connecting to your storage array and you needed more throughput, you'd bond interfaces to get to that storage array so it'd be faster. Just one example.
And there are different modes of running bonded interfaces. So what Nate was just describing is called aggregation, link
Yep.
aggregation, where you're like tying them together into a single interface so you can use bandwidth on both interfaces for traffic, which then gets you more bandwidth in and out of your machine. In my example, I'm going to set up a failover configuration. So I
Yep.
have two NICs set up, and if one dies, the other one just takes over their shared IP address and can start serving it again. So it allows you to have kind of some high availability for your networking, such that if your switch dies and that kills your link, your other interface will start taking over that traffic and dealing with it out of a different switch.
Right.
Um, so there's a whole bunch of different configurations of bonding. But yeah, it's like taking two interfaces, sticking them together to use them as a single device for the system. All right. So um, in the olden times, you would have to have multiple configuration files to describe which interfaces belonged to your bonded interface and then what all the settings were on your bonded interface. But Network Manager actually makes that a lot easier. And you can set this all up through nmcli through a series of commands, similar to what Nate was doing earlier with setting our manual IP address and setting our DNS settings. We can do that with setting up bonded interfaces too. However, um, Red Hat Enterprise Linux comes with the technology called RHEL system roles. RHEL system roles are based on Ansible. So RHEL comes with the set of system roles as well as Ansible-core to help you use the functionality in the system roles. And you basically just write an Ansible playbook. And I've written one here. I used the very inventive name Bond Playbook. But basically, you set up the hosts that you want to apply this change to. So if you had like a whole bunch of hosts that were identical and you wanted to set up the same thing across all of them, you could specify a list of hosts to go out and execute this change across uh, all these different machines automatically. I'm just going to make this change to localhost.
Yeah,
Um,
obviously you wouldn't make that IP address the same on all the hosts, so keep that in mind.
yeah, you may need to like wrap something like this with a little bit more logic to make better decisions, but here we go. So I'm applying this only to localhost, and I'm going to define a new connection called bond zero, and it's going to be turned on, and its type is a bond, right? As opposed to Ethernet or wireless or some of the other types that are available through Network Manager. I'm going to assign it an IP address. So here's the IP address I want it to have. I'm going to assign it some DNS settings, right? Which Nate showed us how to manually change, but we're just going to include it in our configuration here, and some DNS search domains. All right, then I said that bonds have things like different methods of interacting, right? So here, this mode, I'm setting up my bond to be an active backup, right? So one of the network interfaces is going to be responsible for all the traffic unless it dies, in which case it'll all move over to the other network interface. So one of them will be active, one of them will be the backup. And then MIMON, so the way it's going to determine whether an interface dies or it is healthy is by checking its link status. And so this MII monitor is how frequently we should check that link status. And so if you needed it to recognize that the link is down earlier, you could make that number smaller. If you occasionally have weirdnesses in your network, so that if it immediately went down, you might want to hang on for a minute before you shift over to the other interface. You can make it larger. So that's the timeout that is going to occur. All right, and then down towards the bottom, what network interfaces make up my bond? So the first one I'm going to call member one, and it's an Ethernet interface. Here's the interface name, right? This is what it lives in Network Manager as its device name, and it's going to be controlled by bond 0. Member 2, also an Ethernet. It's got a different device name, and it's also going to roll up into bond 0. All right, at the very end, it says I need to load the RHEL system role called network. So that's who's going to parse this list of variables and make these assignments. Now, what's really cool about system roles is they're written and maintained by Red Hat engineers. So they make very good Red Hat decisions, like it knows that Network Manager manages devices. And so even though these devices are going to be members of this new bond, they may have previously been standalone interfaces with their own IP addresses. And so it will actually make changes to them and convert them to be membership of this bond and deconfigure some of the individual things they may have had going on their interfaces. All right. So let's do a Ansible playbook, bond playbook. So it's going through and like checking the status of different things and what are the flags and are we running network manager? Do we have the right software? And then, uh-oh, I get an error message.
This is why we test these things in prod, Scott.
Right. I tested it last night on a different machine, but I had to manually recreate the configuration file. So let's see, invalid key DNS. Okay, so we'll do this just for the sake of getting us back on track. Let's try that. Nope, still no. DNS search. So maybe I have the wrong stuff in there. I tried it last night. We'll just do IP address. The other kind of cool thing about system roles is that later on, when I'm ready to like troubleshoot my DNS settings, I can just add them in to the playbook again. And because the playbook has the same content as before, when it gets to things like configuring the bot interface, that's already done. So it would skip over that part. And then when it gets to the new things like my corrected DNS settings, it would go ahead and apply those changes. All right, so this looks much better. And if I IPA, there's my new bonded network interface with
Yay.
the address that I assigned to it. And you could see, I mentioned earlier that it would deconfigure the others, right? So these guys before had their own IP addresses, but we can see that they've been stripped away and now they're just using these interfaces to service that shared IP address that they both have. All right, so that was pretty quick and easy to set up a bonded interface, and it does all the right Red Hat things and all the right network configuration things thanks to the RHEL system rules. And if you have the wrong stuff in there, notice it produced an error that you could troubleshoot and diagnose, and then just re-execute the system rule once you've got it fixed, and everything will be fine.
Yep. And those features that Scott had to take out do work. He just had probably a typo or something, or a invalid placement of where they were.
Right. Like maybe they were not indented enough or they were indented too much. But as we're getting past time, I don't want to spend a bunch of time troubleshooting it. Maybe
You
another
want to live
troubleshoot.
troubleshoot too? Come on.
Yeah.
Troubleshooting your Ansible playbooks on into the terminal?
Exactly. What could possibly go wrong?
That sounds like a frustrating episode.
Um, so we also get a lot of questions from people who are coming from those kind of more traditional Linux environments where you have a configuration file and you're used to just like dropping a file in a directory and having it good. How do I convert? And our argument, I think, would be, and correct me if I'm wrong, Nate, you should just use Network Manager and nmcli, and you should put that in your automation scripting or your post-installation kickstart scripting as a script, rather than a
Yep.
here doc configuration file you plop somewhere, right? You should use bash shell scripting with nmcli to make the same changes that you were making before, just in a new and more modern way. But some people like files. So Nate, do we have something to tell the people that like files?
Yep. So there's a blog that was written somewhere around the time that RHEL 9 came out, because 9 was when there was kind of the biggest shift in how. I think that's when RHEL stopped reading the old ifcfg files and translating them to these new key files, right? And the blog tells you basically what the key files look like, where to place them, and how to interact with them. But I'm going to tell you that the interaction is you might as well switch over to nmcli scripts instead. Make a bash script that executes nmcli to do the work. The alternative here is you make the key file, and then you have to tell Network Manager to read the key file into the database anyway. It's not like it's reading the key file on the fly, like it did with the old network scripts. So, kind of use at your own risk. If you really need to be able to make files that define your network interfaces, if that just works for your workflow better, the blog helps you understand how to do that.
Yeah, and the big thing is that changes you make to the file are not immediately reflected, right? Even if
Right.
you
Which
put
is kind of
this,
similar to how the network scripts worked in the past. You always had to make the change and then down and then up the interface, right? So I don't know.
but
I guess
now
it's
we have,
similar, but there's a better way now. Why don't you use the better way?
right. So if you use files, it's different, right? You got to make your change in the
Yeah.
file, and then
Yeah.
upload it to the database, and then down and up the interface, or just up the interface so it rereads the
Right.
connection.
Right. Yeah. I mean, from like a workflow perspective, it's like make the change, execute a command to apply the change, which is kind of what you were doing in the past with the networking restart or interface up and down and up. Anyway, my point is, don't do it that way.
Yeah, don't. All right. So our takeaway for today: you want to try some networking stuff yourself with nmcli because it's new to you. We have a lab that is free and interactive. I'll also make sure to put this in the episode guide um, so that you can try this on your own. I'll put the link to the blog there too. Um, but yeah, you can try it on your own and use nmcli and follow our self-paced lab for making this happen. Um, I saw a couple of questions. There's one on how to monitor the bonded interface. So, what is it? IOStat gives you the network in and out. So that'll give you the network in.
Does IOStat give you network? I thought that was for disk.
You're right. Well, man, see, this is what happens. We go off script and try to answer things off the top of our head.
Yeah.
There is
Yeah.
a
There.
blocks being transferred in and out of your machine by networking, and it will also outline what's going in and out through the bonded interface and its components. Um, oh, and Shantanu says NTOP is a
That
good
could be
utility.
true. Yeah. It's been a while since I've had to monitor bonded interfaces. And I think the tools were different when I was doing it. But I think it'll also show you a link status in. Does IP show you link status? I know ethtool used to. Does ethtool still exist?
ETHTool exists, but it's one of the deprecated tools.
Yeah,
I
there's a
think
replacement for it that I'm slipping at the moment.
so. All right, I think that runs us off the bottom of our questions today. Great interactivity in the chat, everybody. Um,
Yeah.
so next week we will be doing another episode, but TBD. We'll publish our card on Monday or Tuesday next week. Actually, it'll be Tuesday because that's when we will be back doing planning.
I thought we'd picked
Uh,
a topic, but I can't remember what it was now. That was
Exactly.
Monday, Scott.
I we did next week, we will also resume the satellite miniseries that
Yep.
Eric and Richard have been doing. So tune in next week for an additional episode of satellite miniseries. I think that's it. Don't forget to like.
Yeah. Yeah, we like it when you like our stuff. So like our stuff. Do it now. Go click the button. Click it
All
twice.
right,
No, not twice. That might unlike it. Have all your friends go click it.
there you go. And if do you think somebody would be benefit from this, don't forget to share it with them.
Yeah.
All right, everyone. We'll see you another time on Into the Terminal.
Have a great one.